Hi everyone. So today is date 13 of the September LeetCoding Challenge 2021, and on this day we have to solve this problem, maximum number of balloons. And in this problem, like we have been given a text, and it is it has got some characters, and we using these characters we have to form instances, as many instances of word balloon as possible. So for example, if you want to form this one word instance of word balloon, we will need one B, one A, two L, two O's, and one N. And we cannot use one character of this word text more than once. So for forming two instances of balloon, we will need twice of these characters. So we can see that in the example, one word of balloon is possible into like these two words, these two instances of balloon are possible. So one instance is highlighted in red and one is highlighted in green. And in third example, like no instance of word balloon is possible. And we can see the constraints that the length of the text is ranging from 1 to 10 power 4. And yeah, so these are the conditions. So we the approach for solving this balloon like this balloon problem is that we can find how many bees are possible in like how many bees are present in the word text, and suppose there are 25 bees. So since we need only one bee for forming one word or balloon, we can divide that 25 by 1 to get how many balloons can be made if we are only considering the requirement of B. Similarly, for these A, we will again dividing the frequency of A by 1 to know how many balloons can be formed if we are only considering the requirement of A. But for L and O, we need to divide the frequency of L and O's in the word text by 2, because we need 2L and 2O for each word balloon to be formed. And yeah, this is the basic approach. So after finding all these possible balloons for consider after only considering only one each character, we can take minimum of all those to know how many instances of word balloon can be formed. So for implementing, we will first calculate the frequency of each character. So I'll be using a vector, and it will have got it will have size 26, and I will initialize it with 0. So here 0 will store the frequency of A, 1 will store frequency of B, and so on. And for finding the frequency, we will consider every character present in what text, and then we will do frequency C minus A plus plus. So this will calculate the frequency. Now we will need to know what are the unique characters present in the word balloon. So one is B, then A, L, O, N. These are the unique characters that are present in the word balloon. So now we need to store what are the requirements of each character for one construction of word balloon. So I will call it required count. So this required count will have, I can initialize it. So the word balloon, so there is need of only one character of B, there is need of one character of A, there is need of two characters of L, two characters of O, and one character of N. So these are the required counts of these characters. Now we can calculate how much balloons can be formed if we are considering only only requirement of each character. So I can initialize it with 0 at first. So we can calculate it by looping over all the characters of the balloon. So the frequency present of each character in the word text will be this, and I will divide it with the required count of that character. And I will store it in numSci. So yeah, so this will store how much balloons can be formed if we are considering only the requirement of B. We are considering only the requirement of A, L, O, and N. So after we have got all these nums, we can return the minimum of all these. So it will be something like this. Now we have got, yeah. So we can analyze the time complexity. So we are iterating over the word text. So here it is order n, and these are order 1 operations. So the time complexity is order n, and space complexity is order 1 also, because we are using a frequency vector of 26 characters. This required, and nums are only of 5 characters. So they have got only 5, the size of 5. So the space complexity is order 1. So we can try to run it on the sample test case. Yeah, it is working. You can submit it. We have got wrong answer. How? Yeah. Sorry. It should be minimum element. I wrote maximum by mistake. So we can submit it. Yeah, it got accepted. So see you guys on day 14.